Hello everyone, I am Dr. Raman. In this section we are going to discuss with analytic function unit MCQ question, multiple choice question. See the first problem. F of z and f of z bar are analytic function of z, then f of z is. So f of z is nothing but u plus iv. F of z bar u minus iv. Now rewrite the form u plus I of minus v. So when f of z is analytic function, then CR equation satisfied, ux equal to vy, uy equal to minus vx. Now this is the equation 1. When f of z bar is analytic, then ux equal to, where v it's minus v, so minus vy, uy equal to minus of minus plus vx, equation 2. Now adding 1 and 2, the left hand side, see ux vx. When I am adding this, 2ux equal to vy minus vy, then ux 0. From this ux equal to 0. Then 2uy equal to minus vx plus vx, therefore 2uy 0, uy 0. Now f dash of z, ux plus I uy. When I substitute ux 0 plus I 0 equal to 0, when integrating f of z equal to c is a constant. Therefore the first option B, constant. And the function f of z is analytic function if when is analytic function, CR equation satisfied analytic function. What is the CR equation? The option A, ux equal to vy, uy equal to minus vx. And then find the real part. Here f of z nothing but u plus iv and e power 2 x plus iy. Then from this e power 2x plus I into 2y, e power 2x, e cos 2y plus I sin 2y, when e power I 2y, then e power 2x cos 2y plus I into e power 2x sin 2y, u plus iv. So this is a real part, this is a imaginary part. Therefore real part is nothing but u equal to e power 2x cos 2y. The option is C. The analytic function with the constant modulus is constant is a property. If u plus iv analytic, then the curve u c1 and v c2, then the constant, it cut orthogonally. F of z e power z, and then see f of z is nothing but w. So u plus iv equal to e power x plus iy. Now this is e power x, e power iy, then e power x cos y plus I sin y. Therefore u plus iv equal to e power x cos y, I into e power x sin y. Therefore u equal to e power x cos y, v equal to e power x sin y. Then differentiate ux uy and then vx vy. So ux means e power x differentiation e power x cos y constant, uy means e power x constant minus sin y. For here vx e power x sin y constant, then e power x constant sin y is cos y. Therefore ux equal to vy, uy equal to minus vx. Therefore CR equation is satisfied. Then analytic everywhere, option A. And the function modulus of z whole square, see here f of z modulus of z square. Now u plus iv equal to x plus iy modulus of square equal to x square plus y square square root, then whole square. This is a x square plus y square when the square root removed. Now the real part is u x square y square, and this is a v 0. So ux equal to 2x, uy equal to 2y, vx equal to 0, Vy equal to 0. Now it's not analytic function, but when z 0, then possible for analytic function. Therefore option A, differentiable at origin. Origin means z equal to 0. Now which one of the following is not analytic means, now the previously we explained here. See, clearly we know that modulus of z whole square is not analytic. Now z bar, u plus iv equal to z bar is nothing but x plus iy, x minus iy. So now it's considered z bar is a modulus of z. Therefore this as usual, when the modulus of z, similar procedure for the previous one, x plus iy. So u plus iv equal to x square, x plus iy modulus is nothing but x square plus y square square root. So now to consider u equal to x square plus y square whole power 1 by 2, v equal to 0. So ux differentiation 1 by 2 x square y square minus, so 1 by 2 minus 1 into 2x, vx is 0. Then uy 1 by 2 x square plus y square power 1 by 2 minus 1 into 2y, then vy 0. Therefore ux not equal to vy, uy not equal to minus vx. This is not analytic. F of z is not analytic. So analytic nowhere, option B. Now ux plus uxx plus uy is a Laplace equation. When the satisfying the Laplace equation, then the function is harmonic function. Then the Laplace equation when satisfied, harmonic function. See, u is given, just check this problem. Ux equal to, consider, see, u equal to xy minus x plus y. Now differentiate with respect to x. Here x variable, here x variable. Therefore x differentiation 1, y minus 1 plus 0. Then uxx 0. Then uy, this is the first one, x constant, y differentiation 1, 0 plus 1. Uyy 0. Therefore uxx plus uyy equal to 0 plus 0 0, satisfying Laplace equation. So u is harmonic function. So option B, harmonic function. Now the form, if f of z regular function of z, then dou square by dou x square plus dou square by dou y square, modulus of f of z square equal to 4 into f dash of z modulus of square. This is the correct proof. If u and v are harmonic, then u plus iv is a analytic function. Application of Millian-Thomson method is to construct the f of z. F of z is nothing but analytic function. Now the transform w equal to 1 by z always maps when is circle into circle. Now this is also the sum of the property. If transformation w equal to c z is known as, where c is real constant represent, then it's a magnification. When the same transformation, when the complex constant representation is a magnification and rotation. And the transformation w equal to z plus c means when c is a complex constant represent, then it's a translation. And the formula for bilinear transformation is a cross ratio is nothing but z minus z1. So I simply mentioned that z minus 1 2 3 by z minus 3 2 1. So this is the way mentioned. Now to consider here z is z1. So z1 minus change the other number 2 3 4. So 2 3 4 by z1 minus 4 3 2. Just change the one number. Therefore this is option B. So the points where the function f dash of z0 is called the critical point. So when the critical point transformation w equal to z square, when z0, then it's a critical point. Then the way invariant point of transformation w equal to 2z plus 6 by z plus 7. Now just invariant, how to calculate invariant point or fixed point, put w equal to z. So z equal to 2z plus 6 by z plus 7. when I'm cross multiplication z plus 7 equal to 2z plus 6. Therefore z square plus 7z minus 2z minus 6 is 0. From this z square plus 5z minus 6 0. So the product is nothing but, so multiplication when minus 6 into 1 minus 6, minus 6 plus 1 minus 5. So this is not possible. So 6 into minus 1 minus 6. So 6 minus 5, 5. So this is a possible. Therefore the roots z minus 1, z plus 6 equal to 0. So z 1 minus 6. So the invariant points are option D. And now here see w, again same, put z equal to w equal to z. Therefore z 2z plus 4i by minus of 1 plus iz, where minus 1 minus iz to cross multiplication of z minus 1 minus iz 2z plus 4i. So minus z minus I z square minus 2z minus 4i 0. From this equation minus I z square minus 3z minus 4i 0. When I multiply I, so minus I square z square minus 3i z minus 4i square. Therefore I square minus 1 minus minus plus z square 3i z plus 4 0. Now the factor 4, when it's happen, see 4i into minus I, therefore minus 4i square 4. Then 4i minus I, when we are adding 3i. So therefore here z point is nothing but 4i. When we multiply this, z equal to z 4i, z plus 4i, then z minus I. So just multiply to check with this. Z square minus zi plus 4i, I think it's a minus, correct? Factor, direct this value. So z equal to 4i minus I. So the option is A. For this term, again w equal to z. So z 1 by z minus 2i, z square minus 2i z equal to 1. From this z square minus 2i z minus 1 0. For this form z minus I whole square. See, when we are expanding this, z square minus 2zi I square plus I square is here a minus b whole square, a square plus b square minus 2ab form. So a square is nothing but z square, then b square I square minus 1 and 2ab, so minus 2zi. Therefore z minus I 0, z equal to I. The option is A. Thank you.